right? Any questions about that one? Like I said, I'm pretty sure we did that one. I just didn't answer them all because of the fact that time constraints. All right. Oh, I did. I think from here on out, either I didn't put in the answer or. All right, so how's the best way to deal with this one? Any ideas? So we got to get that.
We do it in log, right?
Yeah, because we got to undo this. So if we do the common log, that's going to undo that. We also go to do this side, and that's just going to be a prop value we need to approximate. All right, so this right here is just going to give us x is equal to whatever that is, and that's 4.92 log, which is 0.69, and how many do they want? 4, 2 decimal places. So watch that, because it went from 4 on one of them to 2 on this one. So always pay attention to that, 2 decimal places. So 0.69. So solution set. Oh, okay.
Log
Yeah, the log of
4.92.
and then they want us to down. Okay. All right, so this is an E one, but the first thing we got to do is isolate that E. So
Divided on both sides.
exactly, yeah, because you can't really use the ln until you just got a single E there. So this would be 307, right? Thank you. Okay, and then I'm going to ln. That's going to undo this. Get the x out of there. So 3x is equal to ln 307, where x is equal to ln 307 divided by 3. So 1 point, and what does it want? 2 decimal places. $1.91. Okay. Any questions?
No.
Oh, how do they want it? Oh, okay.
The solution set, yeah, would be the LN. Okay.
ln of,
307 over 3.
so I'm gonna put a fraction in there. I fixed it, I'm gonna go back in, should be able to get back in. All right, so solve the following logarithmic equation. There's that one-to-one thing it's called. So it's log base 2. So if we write it as an exponent, it means that x plus 6 is equal to 2 to the third power, correct?
Yes.
Okay, so log base 2, so that means the 2 raised to the third power gives us this. So that's x plus 6 is equal to 8. Let's do the third 8. So x is equal to 2. And we gotta make sure in check. All right. Another way to do it, I mean, you put it in there and it would be 2 plus 6 is 8. The log of 8 is fine. Another way to do it, if they ask for the domain, this right here has got to be greater than 0. So as long as x is greater than -6, we're all right. I already have that, didn't
It's answering it for you because your time was up.
I?
So,
Oh, okay.
yeah.
I get it. All right. At least we know we're right. Okay. I don't know why, because
I think because you was already in the test, even though you changed, took the time off, it still didn't
I guess
snatch
what
the time from you.
I guess what I can do is go back in. It doesn't really matter. All right, so again, we're going to use the product rule to put these two together. All right, see that's log 7. So that's log base 7 of the x times 6x minus 1 is equal to 1. So then this is going to be log 7, 6x squared minus x. All right, so it's base 7. So then that's 6x squared minus x is equal to 7 to the first power. So all we're doing is just writing it as an exponent, okay, in exponential form. And so now this is 6x squared minus x minus 7 is equal to 0. It's a quadratic. And we could go up here and see what our domain is and all that, but let's just solve it first. This factors, and I'm just using trial and error at the same time. But it's, let's see, 6x and x, and we just got to figure it out the sides here. Let's see.
Should be plus and negative, huh?
Yes, plus and negative. We need to have this one be the negative because it's gonna, this one's gonna be the negative because it's
Yeah.
negative plus 1 Wait a second. Ooh. Yeah, and then 6 times 1 is plus 6x, so that leaves us with 1. So that's it. So x is equal to -1. This one's going to create a problem because when you come back and put it in there for that x, it's negative. And it also messes up this other side. What it amounts to is this can't right here be negative, or it can't be negative in here. This other one's not an issue. Because it's going to be 6x is equal to 7, or x is equal to 7/6. So that's how they get that one. And if you put that one back in there to the original one, see, if you put 7/6 there, that's positive. If you take 7/6 times 6, then that's going to be 7 minus 1 is equal to 6. That one works as well. So that's the only solution. If by chance both of the solutions had given you a negative value inside, then there would be no solution. But in this case, one of them works. All right. Let me see what else is left. All right, exponential model A is equal to 1.94.3 e to the 0.011 t, describes the population A of a country in millions t years after 203. All right, use the model to determine the population of the country will be in 200. Oh, when the population will be 239 million. Well, it's just a matter of replacing the A. So 239. So this is A. We want to know when that happens. So we're going to put 239 to 194.3 E to 0.011 T. So we're going to divide both sides by 194.3, right? Because the only way we can solve these exponentials is if we have just a plain exponential there. So that's going to be e to 0.011 t. And what's that equal to? So 1.23. All right, let's do it. I don't trust that. I don't trust that I put everything in right. So double check things. So 1.23. Okay. So now we take the LM of both sides again. Same thing we've been doing. Once we got to 4.4 is what we went back to that. All right, so then this is just going to give you the 0.011 t is equal to the ln of 1.23. 5.23. So then we use y sine 5.0.
Not the T.
Oh, thanks. I'll miss it. Thanks. Whew. Wound up today. I had too much caffeine and I got in here later than usual. It's like, since I've been here twice. Around, back and forth. So it's gonna be a slow day. All right, so we're gonna take the ln of that. 0.011. So it's not right. But 1.23. So it's got to be ln divided by 0.1. There we go. So approximately 18.8 years. All right, which means what? Well, it's 2003 plus 8.
Mine.
221. I guess what it is around it off. 18.8 years, so it's 19, approximately 19.
Yeah.
That's why we need that. So remember that too, because it does say round to the nearest year. So t is equal to 19 years, which means 2003 plus the 19 gives us 2022. Okay. All right, any questions about that one?
No.
No.
All right. All right, in 2000, let's see, what was this other one here? Okay, that's the half-life thing. All right. In 2000, the population of a country was approximately 5.62 million, and by 2069, it had grown to 12 million. Use the exponential growth model in which t is the number of years after 2000 and a to the 0 is in millions to find the exponential growth function. So we got to do two things. Okay, first of all, a to the 0 in 2002. Sorry, in 2000, the population of the country was 5.62. And this is when t is equal to 0, okay? Does that make sense? And then we got an a is equal to 12 million. And that's when t is equal to 69. Make sure I got that right, because the biggest problem with these is making, because when you do these calculations, it's a lot of calculations. You got to make sure things are right.
Where does 69 come from?
2069. So 2000 to 2069, that is 69 years.
Oh,
right?
69 years. Okay.
All right. So let's just pop everything into this. And then we gotta find out what K is, and it's gonna be a 12 up there. That's, no, 69, I'm sorry. So I'm gonna just turn it around. Oh, let's first of all do this. So that's E to the 69, K is equal to 12 over 5.62. And then we take the ln of both sides. Which I'm gonna leave it like that for right now. Just to have the accuracy. All right, so that means E. Which side of the E is going? So 69 K. All right, let's figure that out. All right, so we take the ln of that. And we divide by 69. And something doesn't look right. No, I think that's right. I'm sorry. Let me just double check it because, oh, I was jumping ahead. I was thinking we wouldn't do, but this is just to get the K. All right, so let's just double check it. So that's fine. Two decimal places. So it's just 0.01. All right, so now our growth model is going to be A is equal to 5.62 E to the 0.01 T. Okay. And that's what they got. All right, so the country's population, what will it be in the year, when will it be 13 million? Well, we're just going to put the 13 here and solve it, just like we did before, except this time we're going to get the T out. So I'm going to write it. So 13, 5.62. And when I take the ln on both sides, so 13 divided by 5.62. Ln that value. All right, I'm going to go ahead and proceed. Start it off. So then, so 80 through 4 years. So almost 84 around into the nearest year. So that means adding the 24 to 2000, the 84 to 2000 means 2008. Like I said, these take a long time, so. And when I say long time, I mean, 5 or 10 minutes for 2 parts. All right, an artifact originally had 16 grams of carbon, 14 present. The decay model, A is equal to 16E to the blah, 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 blah. Describes the amount of carbon 14 present after T years. Use the model to determine how many grams of carbon 14 will be present in 9,092 years. All right. All right, so if I'm not mistaken, this is pretty simple, straightforward. Let me write down the values. All right, so all right, and so the amount $16. Okay, so that's the 2 values that I got. Any you see any discrepancy? Did I write them down right? So the T years is 9,092. The amount that we start with is 16. Hold on a second. Oh, wait a minute. No. We're finding A. I'm sorry.
I was about to say,
I'm sorry. I was thinking something crazy. We trying to figure out what the A is. We just need to know the T. I was thinking this was the one where we had to find the whole thing. So all we gotta do is just plug in T on this one. So 16 E to negative 0.00012. And then we're gonna put
121 T.
well, the T is now going to be 9,092, right?
Right, I just wanted you to know you was forgetting the one at behind it.
Thanks, yeah. Should be that covenant class. Ever since we started this virtual class stuff last year. All right. 0.000121 times 9,092 9, 2. So that's negative. And as I said this, I don't think this. That there's a way to do the E on here. So I'm just going to do it over here. That decimal is the same. Sorry. One. All right, that's it. So it comes out to 0.33. So 0.33 grams. Wait a minute, hold on. What did I do? Oh, I didn't multiply it times 6. I'm sorry. It's 16. Hold on a second. There we go. So it's 16 times 0.33, which is approximately equal to 5 grams. All right, so Tamika, what was the problem that you had?
Oh, it was question number 6, pretty much what we doing right here.
Okay.
So I will have to read the whole thing to you.
Well, we're gonna read it and we can see if this didn't help, we'll do another one. So what is it? I'll even type it out to make it shorter.
Okay,
What is it?
you ready?
Go ahead.
Okay, it says the function a equals a with the 0 at the bottom, e. No, it's like down at the bottom.
Yeah, but I can't do that on here. So.
Oh, okay.
Is it-
E negative.
Is it times E? Or
No,
plus?
no. It's not time. Yeah, like, and then the exponential thing, negative 0, like up to the power.
I'm gonna write like this because I thought I could type it, but
Okay.
and it's E to the
Negative 0.00990 x.
X.
Models the amount in pounds.
Whoa, what now?
Models, MODELS.
Oh, okay. I see what you're
Yeah.
saying. Okay.
Yeah.
That's the formula.
Yes.
Miles, the pounds.
The amount in pounds. Of a particular radioactive material stored in a concrete vault.
Okay. How many years?
Huh?
Does it say how many years?
No.
Okay, well, I mean, the thing is, the concrete walls not really that important. But I was trying to see if there was more information.
No, and it says where X is the number of years since the material was put into the vault,
Okay.
period.
Mhm.
If 700 pounds of the material are placed in the vault, comma, how much time will need to pass for only 107 pounds?
So 107 pounds remains.
Oh, to remain, question mark, round to the nearest whole number.
All right, I think I can do this one fairly quickly here. Let's just see.
The answer that I got was 190 years.
Okay. And it's saying that that's not right.
It said it was, but I just wanted to make sure that I didn't exactly get 190 years. I rounded a little bit. I think I was like maybe 2 numbers off, but I had to keep doing it and doing it and doing it. But I just want to see how you work it out to make sure I was doing it right.
It was 0.6099. What was that? Is that a 6?
It was negative 0.00990x.
All right, so is that the way you set it up?
I didn't have where you got the 6 from?
Oh, that's a 0?
Yeah, that's a 0. Yeah.
All right. That's why I wanted to type. Because I don't have that good anyway. Especially with this. All right, so E. Yeah, this is pretty much just like when we just took down. So then we're going to LN this thing to get it out of its cage up there. All right, so then this is going to pop out and it's negative 0.00990x is equal to the ln of 107 over 700. So we'll come up here. X is equal to all right, so let's figure that out. $190 years. So 190 years?
Yep, that's right. But I don't know, because I think I put the negative sign on it. I didn't see you put the negative on yours. And I think that's what messed me up on the calculator.
I put in the 0.00990, and then I hit this key right there, the positive negative, before I divide it.
Oh,
You can see it right there, that's where I did it.
okay.
All right, so, well, what about this task thing? Do y'all wanna me to span it over until next Monday? I mean, I'll just say this, all right?
Can you do that?
I will do it, like I said, I just don't like doing it, spanning things over a holiday. I wouldn't, but we can play like everything from tomorrow to Sunday doesn't count, but Monday it'd be, your test day by then, okay?
Thank you so much.
All right, well, I just, did it the way I thought was best. Because I said, I don't want to give the impression, I don't want people to work on holidays and such. All right, so it's 29. So just remember that let's save for later option on the quiz. Someone put yes. Test. So 11:29, so it's Monday. So as I had said is, please do me that favor of bringing in, try to work out the review as much as you can, all right? Because like I said, it really helps me if I got students that worked on them and know what they don't know, because that thing's probably got 40 some problems. I don't know if we have enough time to go through everything. All right, so any questions? I want to get out a little bit early today we can, because I don't have much of a break in between this 2 o'clock class and I need to run to the other building to get
No,
before I start.
I
But
think
anyway.
you're going over that problem for me, but I don't have any questions. Thank you, Mr. Cruz.
All right, and just remember, the exam is December 8th at 3:30 in room 110 across the hall. I think that was original room anyway. I should be able to do it. Yeah, I should be here. Unless something happens to me. I'll be here. We don't have a problem with, the only time we have that, we have a lot of classes and we're not having that right now because there's other virtual classes that are not using the rooms. All right, so if you got questions, feel free to type up. I don't see Sydney up there.
You don't have me checked off. I'm here.
I said Sydney went out of town or something. All right, well, have a happy Thanksgiving.
Same to you, Professor. Thank you so much. Y'all have a good
If
holiday.
you see anything that looks strange, let me know before morning because I'm not going to check in after morning until next Monday. So.
Did you you took the time limit off the practice test, right?
Yes, I did.
Okay, thanks, Professor. Have a good one.
Okay, you're welcome. I'm going to make sure I also took out